Yeah, I'm happy to. Thank you, Nathan. So first introductions all the way around. We have Nathan Wilkerson, our VP of Engineering, Stacy Gordon, our Director of AWS Alliances Global, Ray Pocius, Data Engineer, and a SME, a subject matter expert within the machine learning space. And I am your friendly neighborhood CEO. Diving into the agenda, we've got the introduction, Metal Toad overview. We'll be talking about what the market is getting wrong in ML. That's brand new. It happens to coincide with the newsletter I just sent out. And then we will look specifically at identifying ML problems and then some of the case studies or examples. We'll talk a little bit about AWS POC funding, which is a tool that is available for everybody out there working with an AWS partner. And then we'll open it up for questions from everybody who is in attendance. So first, who is Metal Toad? We're an AWS consulting partner. We have a number of accreditations and competencies. We've worked with a number of household name brands, including the Recording Academy, DC Comics, Intel, Wheel of Fortune, other fantastic companies to work with. Our accreditations include not only our machine learning competency, but a number of other service deliveries and other certifications. Upcoming webinars, because we do this on a regular basis, we will be talking on the 16th of the coming month about generative AI, Bedrock. So that is Amazon's answer to ChatGPT. And then we have a reInvent roundtable highlights scheduled for December 5th. So first, I'm going to dive into what the market is getting wrong with ML. So I came across a statistic on Crunchbase the other day that 1 in 4 investment dollars in the United States are in AI ML. That's for 2023. That's up by 100%. So it's double of what was spending in AI ML last year, which is an incredible rise. And when you stop to think about all of the investment opportunities that exist, for 25% of them to be flowing to AI ML really speaks to the buzz, the excitement of where people are in terms of what they think the future of machine learning is going to be. But really, investors are chasing the wrong things. And this stems from a lack of understanding around AI and ML, but they're looking for genius. They're looking for the next big idea, or they're looking for, the killer technology. So each one of those is problematic and is not really what people should be looking for. First of all, because you don't need to be a genius to use ML. There are a number of systems that are out there. You definitely do need to be smart. You have to like math. And there are certain workflows and other things that Ray and Nathan are going to be talking about, looking at, some of the specifics. But first and foremost, you don't need to be uniquely smart. So then ideas. So some people are looking for the killer idea, right? The problem is ideas can be copied and then sold for less. So if you've ever seen something about Mary and you've the 8-minute abs, you have the guy who's inventing 7-minute abs and he's going to disrupt the whole market until it's pointed out that you could always come up with 6-minute abs. So that's another problem there. The other problem with the killer tech is that the tech is actually widely available. So we'll go over quite a bit of this in terms of in broad terms in this presentation. The other problem with all three of these points, the genius or the idea or the technology, is that none of these are protected from legal challenges. So really, what is left? What should people be looking for in terms of investment? And the answer is data. And so when it comes to AI ML, I think it's important to know that you are not late. Really, I think that every industry will be transformed, but it will be transformed by the companies who understand the industry and who have the data to back it up. So the prompt I'd love to encourage everybody to think about as they're going through the rest of this presentation is, what is your data edge? What data do you have that is unique to you that you can put to work in AI ML workloads? And I'll turn it over with that in terms of identifying ML problems to Nathan. Nathan, you're up.
Well, thank you, Joaquin. Can we go to the next slide? All right, so we've just talked about data and transforming your industry, and you want to do that, but where do you start? And so this is the well-architected machine learning lifecycle. It's published by Amazon. And today we're going to look at the business goal and ML problem framing. It's good to know this whole thing exists so you know exactly what you're getting yourself into. And it's good to know that there are several stages with which you should consider moving back if something doesn't work out. Don't just keep blindly going ahead. Machine learning is a very iterative process. Next slide, please. So identifying a business goal, it's a lot like identifying a business goal for any initiative you have. You want to identify clear problems. You want to identify how you're going to measure success. What are the KPIs there? What's the ROI going to be? Who are the stakeholders who have to have input into this and who will sponsor it at the executive level? And a lot of these can be done by asking questions to yourself. What's the problem you want to solve? If you don't have a problem to solve, why are you doing it? What is your target ROI? Do you want it to pay off in a year? Do you have a 3-year ROI target? Once you have this, you can make important business decisions around how much investment you should do up front and how much you should come back to. So next slide, please. All right, so you have a business problem. And here's the next task, is determining whether you should be doing ML with it or not. Because the first rule of ML, it's really complicated, is don't use ML. And so if your task is really complicated, highly repetitive, something you're doing every day, or you can't, solve it with traditional means, spreadsheet formulas, if-then statements, ML may be a very good tool for you, and you should look at using it. But if you're on the other side of it, where it's a super simple task, or it's something that you've solved before, you were just trying to avoid solving it again, but it's programmatically possible, great. Don't use ML for it. Just do it the traditional way. And the last most important one is, does data exist for it? If you don't have the data you think you'll need, it's good to either pause and gather the data or rethink your question in a way you can answer it with the data you have. Next slide, please. All right, so you have your business question. You know whether it should be an ML problem or not. But now you need to frame it as an ML problem, on a hypothesis. So you take your business question and you transform it into a hypothesis you can prove or disprove with concrete metrics. So not just if sales are better by how much? Not just, is it a bad call? Is it a bad call because X happened on it? The person was upset, something like that. And once you have that, you can validate these are machine learning problems. You can figure out your KPIs, your ROIs. This flushes all that out for you. And if all that looks good, you go to the next phase, which is the data, which we're going to not go into today because that gets a lot more complicated. Instead, next slide, we'll hand it over to Ray, who will go over some of our case studies on these sorts of things.
Great. So next I'll be going over a set of example machine learning areas and problems. For each, we'll go over a business problem, how the problem is framed more towards being an ML problem, and our case study. We as Meltoad help guide our clients through determining how and when they can use ML to gain value from their data to solve their business problems. And you'll see in these examples that framing these problems really comes down to what kind of data you have. Next slide. So the first machine learning area and problem that I'll talk about is computer vision. And what this is, it's a field in AI and ML that focuses on algorithms to infer information from images, basically to help computers understand images and what's in them. Examples of this can be object detection, finding certain objects within images, image classification, determining what those objects are, and even generative methods such as like a style transfer, transferring the style of one image to another. iOne Digital, a digital media company, came to Meltoad with the problem of identifying a particular actor in hours of video footage. So they wanted to collect all this footage and compile it together. So the task and the business problem became, given a set of videos, I want to identify all scenes that contain a specific actor. And this ended up being the perfect computer vision problem. The ML problem ended up being, given a set of images and the image of an actor, identify all images in that set that have that given person in them. And in this case, a video is represented as a set of images. So we used AWS recognition to perform this task of identifying that actor across all video footage for our client. Next slide. The next machine learning problem, an area, is natural language processing. So natural language processing is the field of basically modeling human language using ML and algorithms. And potential applications for this can be text classification or even sentiment analysis. So Genius Vets is a platform for veterinarians, and they came to us with this problem of having to identify what calls to a clinic were negative. They wanted to tag these calls automatically so that they can provide feedback to their call receptionists. So the business problem was that they have a large number of recorded veterinarian clinic calls in MP3 format, and they need to know which ones are the worst. So to frame this as a natural language processing problem, we converted all of their call data into text using AWS Transcribe, and then analyzed that text according to Genius Vet's criteria on what is a negative call. And then we use services such as AWS Comprehend and custom algorithms such as blazing text to perform sentiment analysis on that, and then to label which calls were negative for further review. Next slide. The next machine learning area I'll talk about is generative AI. So Gen AI is an area of machine learning which involves algorithms that are capable of generating text or images or other forms of media. They're really great at learning patterns in their training data and then generating new data with similar characteristics. So beyond just using AWS Comprehend to determine the sentiment of these calls, Genius Vets wanted to identify particular characteristics of the call, determining specific sentiments such as anxiety, concern, or confusion, and also specific events such as an appointment being scheduled or the cost of the service being explained over the phone. So the business problem became, given a large number of recorded veterinarian clinic calls, I need to know the characteristics of them or what events occurred within them. So the ML problem became, given text transcripts that were created using AWS Transcribe, identify then certain characteristics and events in those transcripts. So we chose to use a large language model on Amazon Bedrock and engineered prompts to take in the transcriptions of the calls and then to identify key characteristics, which were defined by our client. We also asked it to return the response as a JSON format to integrate seamlessly with their system and their dashboard. And you can see an example of that output on the right, which is able to identify whether there was anxiety, confusion in the call or concern, or whether specific events occurred within a call, such as making an appointment. And it can also provide summaries as well. Next slide. The next area I'll talk about is anomaly detection. So we have a client named SecureToad, which came to us with the business need of identifying suspicious activity on their sites so that they can block those IP addresses. So the business problem became, given a set of IP addresses and the resources they're trying to access, which ones are suspicious? Which ones can I block? So this ML problem became then, given a set of events, which ones are anomalous? The anomalous ones being the most suspicious. So we selected the ideal algorithm to solve this problem for them and generated event scores, which basically indicated how anomalous a certain event was. And then we communicated with the client what kind of threshold of activity would we like to allow for their sites. Next slide. Reinforcement learning is another area of ML that I'm going to talk about. Some example business problems for this kind of problem would be, for example, a client having an online game and needing a bot, an AI bot for people to play against. So this can be framed into an ML problem. So given a game or a particular like simulated environment, I need an algorithm or model that can optimally play or solve this game. In reinforcement learning, an ML agent learns through experience by playing the game and accumulating reward for correctly solving it or winning the game. So as the agent learns, the agent gets better at accumulating reward and then consequently winning the game. So this model can then be deployed in a production level environment for multiple people to play against once it's learned how to successfully solve the game and play a wide range of different players. Some other applications of reinforcement learning also include autonomous cars and robotics. Next slide. Graph machine learning is another area of ML. Many companies have data that can be stored as a graph. A graph is a set of nodes and a set of edges. So that you can see on the right, there's an example graph here of two users, maybe on some media platform, that are watching the same kids' television program. So other examples of graphs could be social networking sites, such as Facebook or Pinterest. And the objective of GraphML is we'd want to recommend content to people or suggest particular users to other people. So if you have data that can be properly represented as a graph, something similar to what we have on the right, then you can apply GraphML to it to either predict certain attributes about users. So if one user had, I watched this particular kids program, but they didn't fill in their age, those are kind of things that you can predict using GraphML. Or if a user hasn't watched a particular TV program, you can recommend it to them based on the history of users who have watched a certain program. So in the example on the right, if a user is around the same age as the other user who watches the TV program, then GraphML will then suggest that program to them. So this works really great for content recommendation as well, and is a kind of ML algorithm that can improve over time as you collect more and more data about your social network. Next slide. So the final area of machine learning that I'll go over is an area called dimensionality reduction and also clustering. So we had a client, RPG Match, which is a social networking site for tabletop RPG players, who we worked with to determine basically the similarity between different users' data on the platform. So the business problem became, given a set of users, I want to find out which users are similar to each other, given their characteristics, to maybe recommend them to each other. So the ML problem becomes, given a user with dimension n of data, so n number of attributes or characteristics of the user, determine the similarity between those two users when they're mapped into some 2D space, where we can really see the similarity between two users a lot more easily. So once in this space, we can also use something that's called clustering to find groups of users who have very similar characteristics. So you can see on the graph on the right there that 3 different clusters of similarly grouped data were identified, and maybe those users are very similar to each other. And with that, you can identify different types of users on your platform. Now you can start to see how we can take companies' data, their business problems, the objectives, and then formulate all of that into an ML problem that can be solved and deployed. And with that, I'll hand this over to Joaquin to talk about our proof of concept funding opportunity.
Great. Thanks so much, Ray. So diving into ML problems, you might say, hey, I want to do an ML project, but I don't have any money, or I'm not sure where I would get funding for it. AWS wants to help you. So AWS has a program called Proof of Concept Funding, and we can apply that to ML projects. So I'm going to go through fairly rapidly what is an AWS POC, or Proof of Concept, AWS partner requirements, funding availability, and then payment structure. So first, to start off, what is a POC? So a POC is a small scale project for customers who are exploring new AWS workloads. So it's not for existing customers with existing work, but it can be for existing AWS customers who are looking to explore something. So if you have a new idea, for example, for an ML project, that would be a perfect example of a new workload, even if you are an existing customer. And so by design, what you're really trying to do is figure out, hey, is this AWS solution going to work at scale in the way that I need to? And so if that succeeds, then the customer expectation is that, hey, that works. you're going to use AWS for that product, but it can be figuring out what's the cost going to be, what sort of algorithm do I want to use. There are a number of different ways that you can approach the same business problem. And so this is a great way to work through how that solution would actually work in real time. A partner requirement. So to qualify for POC funding, they don't just hand it out to anybody, but anybody who's working with a qualified partner like Metaltoad can get access to this funding. So for the partner to qualify, they have to be at the validated stage or higher on software services or hardware partner path. So Metaltoad is both a software and a services partner. We haven't done the hardware path yet, but there are plenty of AWS partners that are out there if you wanted to pursue that. So funding. Okay, so at the end of the day, how much do they pay? What AWS does is they look at the amount of ARR, or annual recurring revenue, that would be spent with AWS. And they say, okay, great, we'll pay 10% of that for you to explore this project. There is a limitation there. If you're going to be spending more than $250,000 in annual recurring revenue, the maximum for this particular program is $25,000. However, there are other programs that exist for that larger spend, and they're actually even more generous. So if you do have a significantly large workload, that's something where you can actually qualify for even more funding. The payment structure, the cash is paid at project completion. Credits are issued upfront. That would be credits for the AWS workload itself. And this last piece is very important. It requires a few weeks for pre-approval. That process you go through, you create a calculator with your AWS partner, and then that would be greenlit by AWS on the other side. So a summary of all of that is right here. What's a POC, AWS partner eligibility, funding availability, and then the payment structure. You can either take a screenshot of that, or we'd be happy to email you. And we've got Stacy Gordon here, who would be happy to help you if you have a project.
Right.
So thank you for those who attended. We've got a couple extra minutes. We're happy to stick around, answer any questions that people might have. If you do have any follow-up projects that you would like help with, we've got Stacy Gordon here. You want to say hi, Stacy?
Hello, everyone.
So she'd be happy to help you with that. Otherwise, thank you so much for attending. We hope this was helpful.